Hello, I'm Mark Langelo, Key Account Manager with Dynapar. I'm here today to demonstrate to you how to test an encoder using both an oscilloscope and our RIM test kit. I've gone ahead and set up the oscilloscope, connected it to our RIM signal splitter. The output is coming from this optical HS35R. What you can see from just the output and the waveforms on the oscilloscope is that number one, A is connected to channel 1 and B is connected to channel 2, and that the waveforms are both even to each other, so the falling plot and the rising plot are even to each other. So that's an indication that the on and off times from the encoder are correct. The other thing that you can look at from the waveforms is see that the waveform from A to B is about 90 degrees out of phase. You can use the position to give you further indication. When you see that the waveforms bisect each other with 50% of duty cycle on either side, this is an indication that the phase relationship between A and B is also correct. Another check that you can do to verify if the pulse output is continuous from the encoder is change the scale so that the pulse output fills the screen. If there are any missing pulses from the encoder, you'd see gaps in this, and this would be an indication that there would be some issue with the encoder, either an intermittency or some type of pollution on the disk. So after you've checked the duty cycle or symmetry of the signal and the phase relationship, one of the last things that you can do is also verify if the encoder has an index, that it's present. So I have a secondary scope probe for that. In order to do that, you have to change the trigger from the A and B over to the Z. Now you can see without the proper trigger that the channels move back and forth. That's just because we're now triggering on the third channel. Then when we plug it in, there we can see the Z channel. So now we've verified proper operation between A, B, and that we have a Z pulse. In the close-up, you'll be able to see that we have both duty cycle, phase relationship, and the frequency output displayed. Each of those are also the indication that the encoder is working properly. So now moving on to the RIM test kit. The setup is a little simpler in terms of the fact that the RIM test kit comes with the complementary input cable that hooks directly into the TAC. The unit powers the encoder itself, so there's not an external power supply that's required. So I'm going to go ahead and turn on the drive. So the first function that we'll test is we'll take a look at the A pulse. Again, symmetry of the output of the encoder is shown here. It's approximately 50%, which is the same value that we were seeing on the oscilloscope. And then also the phase relationship between A and B is shown on the right-hand side. There's an actual min and max displayed for each one. B is toggling between 50 and 49%, and min-max of minimum of 40% duty cycle or symmetry, and a maximum of 53, and the phase relationship is also shown. In addition to the functional check of the output, you can also verify the motor RPM by inputting the encoder PPR, and now the motor output RPM is displayed. In summary, I've demonstrated two different ways for you to go through and check the encoder, both via an oscilloscope and via the RIM test kit. Either one are useful tools when you're doing a new setup for a new installation of an encoder, or you're trying to do some troubleshooting to backtrack if issues, trips or faults are being caused by the encoder or elsewhere in your system. I hope the demonstration has been informative. Please visit our website for more information at dynapar.com.